detection. So I'm going to take one example about fraud detection, right? And then the social media analysis in terms of sentiment analysis, etc. So practically, no walk of life today is without data and is without data science application. So therefore, let us look at exactly how things work, where industry gets benefited, where you get benefited as a consumer. Now, before we get into the application, every industry that tries to adopt data science has an acid test before it starts the journey of use of data science. And the reason is simple because data science, as we have seen, requires huge infrastructure in terms of processing capability, like data storage, computing capability, in terms of algorithms, softwares, and also skilled manpower, which is today very rare to get. So before they start or embark on their journey, they have their acid tests. What they want from this data science journey is, one, whether it will help me increase or sustain my revenue by either adding new customers or by cross-selling or upselling to existing customers. What is meant by cross-sell? Cross-sell means if you have product A, will you be buying product B? So for example, if you have bought, let's say, washing machine from me, will you buy my dishwasher or will you buy my vacuum cleaner? So in FMCG category, I'm trying to cross-sell to you different products. What is meant by upsell? Upsell is, if you have bought a Maruti 800 car, will you now buy an SUV from me? So will you buy my Brezza car? So that is called as upsell. So basically upgrading the equipment or service that you have bought from me. So first we'll say whether it is help me to increase or sustain revenue. Two, will it increase my profit? If I'm going to invest, will it help me to reduce my costs or avoid my wastage? And thirdly, will it increase my customer loyalty by one, improving customer satisfaction or by enriching the customer experience? And whenever now we talk about the applications, we will touch upon these topics as to how the data science is being used by various organizations, enterprises, to ensure that they get either one, two, or all three benefits from their data science journey. So let me take the most popular example of a cab ride, Ola. And I'm sure many of you have experienced either Ola, Uber, or for that matter, any other taxi service provider. Now, the reason why I have taken Ola, because it actually encompasses all the three dimensions that we talked about. It targets to increase the revenue, it targets to increase profit, and it targets to increase the loyalty of the customer. It takes help of what is known as dynamic pricing. So let me first tell you what is dynamic pricing. So we have static pricing, we have slab-based pricing, and we have dynamic pricing. Static pricing is, the standard term that you read on any grocery shop. The goods are sold at MRP. So whether you are a black guy or a white guy, you are a lady or a gentleman, you are a kid or a grown-up, you stay in my area, doesn't stay in my area, irrespective of the customer caste, creed, gender, color, paying ability, it's the same price. That is called as MRP. And that is where I sold the goods at MRP. Then there is something called as slab pricing. So the most common example is our electricity bills. Up to 100 units, you have one rate. 100 to 300 units, you have another rate. 300 and more, there is another third rate. So this is called as slab pricing. While dynamic pricing is much above all this. It changes from customer to customer, from time to time, from day to day. It is actually based on situation. It is actually based on individual customer behavior. That is why it is called as dynamic pricing. So if you want to, let's say, buy soap, now a soap normally is sold at MRP. But if I come and say, oh, no, you stay in Wardha, so your soap price to you is 50 rupees, while you stay in Nagpur and therefore soap price is 40 rupees. or you stay in Pune, so price is 25 rupees. That is not how the dynamic pricing, not the static pricing work. But the dynamic pricing will only say that, oh, Mr. Patil, it will cost you 25 rupees, even if you are from Varda. And Mr. Gende, this is 26 rupees to you. That is what is dynamic pricing based on the customer behavior. So how Ola operates and why they need data science behind this? Basically, Ola handles structured data. So what are the characteristics that we learn? That okay, so you have your mobile number as an identity. Then you know where you are booking the car from, what is your starting point, what is your destination, what time of the day, and then they will give you an estimated price. So let me take an example. Yeah, I stay in Kothurud area in Pune. I go to Hinjewadi for my work. My office timings are 9 to 6 p.m. So basically, I try and book a ride at around 8 o'clock so that, by the time 8:15 the car comes in and 9 o'clock I reach my office. So Monday morning, I booked a ride and they gave me an estimate of 300 rupees. So I thought it was fair. 22 kilometers from my home, 45 minutes ride, 300 rupees is a fair price. So I booked the cab. I took the cab ride. I went to office, reached in time. I was happy. Tuesday, I did the same thing, got the same result. 300 rupees estimated price, the same behavior. Wednesday, the same behavior. Come Thursday, again I booked the ride at 8 o'clock. Now the price estimate that I got is 310 rupees. So I'm okay, 300, 310, hardly any difference, 2-3%. I'm okay to pay 310. So I still book a ride. Now this is the first use of structured data, dynamic pricing, and data science. What at the background is happening is this guy is traveling every day from 8 o'clock, around 8 o'clock. So he is going to go to a fixed destination. So looks like it is an office because this is office time, this is office destination. So he will not mind paying a little more than what I have been offering him as a fair price. So they charge me 310. I basically booked the cab and I took the ride. See here, what was available at 300. So they had a profit of, let's assume 10%, 30 rupees profit. They increased the price. So they increased the revenue from 300 to 310. And they increased the profit from 30 to 40 rupees. Straight 33% rise in their profit. Now they did that for me even for Friday because now they know that at 310 this guy is okay to buy my service. So they charge me again 310. On Monday next week, they charge me 325 rupees. I said, look, 325 Monday morning looks like a busy day, start of the week. I also have meetings lined up. So let me book the ride. I don't want to kind of do more window shopping and see who is offering a better price. Let me take 325. So here again, now you see the same phenomenon. They have understood that I am not a guy who will for 5 or 10 rupees, start looking at other cab services. So they charge me 325. Again, increase in revenue, increase in profit. So Monday, Tuesday, Wednesday, same thing happened. Thursday, they jacked up the price to 335 rupees. So my antenna went up. I said, look, 310, it was okay to 3%, even 325 was okay, but 335 is not the right price. It is more than 10% rise. And practically, there is nothing that has caused the rise in pricing because fuel prices are steady. My starting point, ending point is same, timing is same. So why these guys should charge me 335? I will not book Ola, I will take Uber. So now you have learned that first 3 days 300, next 2 days 10 rupees extra, 20 rupees. Following 3 days 25 rupees extra over and above their normal pricing. So in the process of about 8 days, they have earned 95 rupees extra from me. Increase revenue, increase profit. By knowing my behavior that I will go to office at 8 o'clock, I am a little elastic guy. But as soon as I reject the ride at 335, they also noted that my price elasticity has ended. The price range that I'm okay with is probably from 300 to 325. So they have done the customer behavior analysis, and then they have started increasing the price till a point I make a decision to shift to any other ride. So when you reject the price, they realize that I'm going to take some other ride. You saw that they met their first objective of increase revenue, increase profit. So because I rejected the ride on Thursday, what happens on Friday? They don't keep quiet. Suddenly, a Ola message will pop up on your mobile at around 7:45. Your next Ola ride, 20 rupees off. And now you want to book, obviously, because then you put the same details, same starting point, same destination. They will say 310 rupees, 20 rupees off, you go at 290 rupees. So imagine now that you thought, oh, great deal. Earlier I was paying 310, today I have 290. So I am saving at least 10, 20 rupees. So I book the ride. So what happened? They won back the customer loyalty. The customer who went to other service providers of taxi service, they won back the loyalty. And that too by not paying any single extra rupee from their pocket. The 20 rupees that they return, of which they had already taken 90 rupees from me, and now they are not offering 20 rupees actually as a discount. They are just offering 10 rupees because at a 300 price level, they were anyway making 30 rupees as a profit. So what they have done is really at the loss of notional 10 rupee profit, which is again not from their pocket, they have won back the customer confidence. So overall, in the process of 2 weeks ride, they actually garnered 80 rupees extra profit and extra revenue and won back the customer loyalty. Now, this is all possible because they constantly keep tracking my behavior. The data processing at the back is constantly happening. Now, because I gave you my example, you may think that, oh, this is not a big deal. These are some 6, 7 transactions of one individual. But just imagine Ola has a central server of cab booking, central software to manage cab booking. The kind of infrastructure they would have, they would store data of all their riders throughout the year, throughout the day, throughout the month. So they are using all these technologies of distributed data processing, simultaneous data processing, instant data processing, high computing data processing. So they probably would have chosen, technologies to store distributed data, because when I go from when I'm operating in Pune, my data may remain on Pune server. But if I go, let us say in Chandigarh, my data is still accessible there because my mobile number is same. So they basically will know, and then they will track my history and say, oh, for 22 kilometers, this guy was okay for 300 to 325 rupees price. So even if he is in Chandigarh, the customer behavior will remain the same. And therefore, they will try and make use of that information to do or to give the price estimate for my ride. This is a classic example of how a particular enterprise, it's not only Ola, it's also Uber, it's also other taxi service providers, those who have embarked on their data science journey, they will experience, they will use this technology, and you will have similar experience here. So from a customer perspective now, it's not such a great thing because they are taking advantage of tracking your behavior and offering a pricing that is based on a situation which is very specific to you. Now it is possible that I was okay for the first rise of 300 to 310. There may be a very picky customer who says, no, yesterday I paid 300, why should I pay 310 today? If you are not giving me 300, I will take another ride or I will find my way to travel. So they will not play this kind of tricks with the guy who is very clear in terms of what price he pays. And this is how that dynamism comes in. So price to you is different than price to me. Maybe you are also staying in Kothurud, you are also going to Hinjawadi, but you are more strict on your pricing and paying capability or your willingness to pay. While somebody who may even buy the ride at 335, so he is more price elastic than me, while you are probably not as price elastic as I am. So depending on the behavior of the customer, the pricing is decided. And that's why it is called as dynamic pricing. So this is the first example of how dynamic pricing as a technique in data science is used to increase revenue, increase profit, and bring back customer loyalty. The second example of customer behavior analysis, earlier we process structured data, while this is an example of unstructured data. And it is an example of what is known as anomaly detection in the data science language. Now, frankly, is it anomaly detection is such a new thing to us? No, we all know in early years of our education, we know anomalous expansion of water. That, normal any other substance increases volume when it is heated, while water is, when it freezes, it increases volume. The volume of ice is more than volume of water of the same quantity. So similarly, all of us have been some time or other class monitors. And what do? You do exactly the same thing, anomaly detection, because your class teacher says, okay, Satish, you are a class monitor, so you should tell me the guys, who are coming late to the classes or who are coming late to the school, because school allows 9 a.m. to 9:10 a.m. as permissible time. So I have a class of 50 students, and what I have to do, I have to just look at who comes after 10 past 9, right? So basically, I'm doing anomaly detection because the normal expected behavior is I come to school between 9 and 10 past 9. Now here it is very simple because it is by observation, as the data set is very small. Only 50 people, 50 students coming in through the same entrance. But just imagine that you are made monitor of a big gathering where people are assembling at a particular location on a ground for a big procession. Everybody is supposed to be in at 9 a.m. and there are multiple entrances. Now, can you alone do that kind of observation and say, okay, these many people came late? No, you cannot, because the data set is larger, the complexity has gone up, volume of data has gone up. Now there will be thousands of people coming in. But you still do the function of anomaly detection. While here it's a small domain, but still it's a complex domain. This is a picture of a bank branch, and you see a person sitting there, and I have put a circle around him. So what is the use case here? Use case here is the CCTV camera at the entrance of the branch, which takes pictures and videos of all the people coming in and what is happening in the branch. These video films are sent back to the data processing engine, and the data processing engine tries to identify anomalic behavior of the bank customers coming in. Now, what is the normal customer behavior expected? That the customer will walk in, go to some counter, go to some ATM, or transact some business, and in about 10-15 minutes time, he will go away. While now this guy is sitting there for 15 minutes, he is not talking to any of the bank officials, he is not conducting any transaction, and he is just sitting there. So when this video analysis is done at the back, which is unstructured data, so frame by frame, this data is processed, and the data processing algorithm gives an insight that there is an individual who is showing anomalic behavior, that he has not moved from his chair for last 15 minutes. So this is an insight that the anomaly detection algorithm has given by processing unstructured data in the form of a video. As you understood in the earlier session that there is a process, so you need to apply the business context. So what is the possibility? Possibility one, that he is potentially an unhappy customer because he expects somebody from the branch to attend to him while he is not being attended for last 15 minutes. So he will get upset, he may not do any business with us, go away, close his account or whatever. So you have a potentially unhappy customer. So the branch manager gets a message saying that there is a customer who is not attended for last 15 minutes, he has not moved from his chair. At the same time, there is a possibility that this particular person is actually not a customer, but he has some potential fraudulent or malicious intent. So he is actually waiting for opportunity. So all you know, he may be a robber. He is just waiting for opportunity. There are so many people transacting business, as you can see, 1, 2, 3, 4, 5, 6, 7, 8. So he is expecting that, when the crowd goes down and there are only bank staff, I will go and do my robbery job. So a message also goes to a security head saying that, look, there seems to be some anomaly in the behavior of the customer. So please keep a watch. All you know is he could be a customer. He has a genuine reason to sit down. Maybe he's waiting for somebody to come in and then transact the business. So you cannot directly take any action. But this kind of data processing actually alerts several mechanisms that can come into place to either one, address the potential unhappy customer, or to avoid a potential fraudulent customer. So this is how a customer behavior analysis is done when there is an unstructured data being processed. And this technique is called as anomaly detection technique by processing unstructured data through data science algorithms. Potentially, what can happen? The branch manager come ask him, sir, do you need help, or madam, do you need help? And the guy or the lady will be happy because he's attended. Branch manager personally came in, solved his problem. So we will increase the loyalty of the customer. Or if he has a malicious intention anyway, the security guard will come and check what is the intent, and maybe you can avoid a potential disaster. So both ways, if it was avoidance of potential disaster, that means you have reduced the wastage. So one basic objective of having a data science background. And two, you have potentially gained the loyalty of the customer. So here there may not be a direct revenue increase, but certainly the increase in loyalty and avoiding wastage. The third example I want to give, again, this is very close to all of us, and you must have already experienced it. I do experience it many times. I do a lot of, or rather, I used to do a lot of air travel and book tickets myself. Now, this is a use case of how a typical airline uses dynamic pricing to ensure that the customer buys their air tickets and not any other airline ticket. So here what happens is, you start looking at various airlines. You know what destination you want to go, what day, what time, and typically what is your price range or what is your budget. So you basically start looking at, okay, Go Air, Indigo, Air India, and whatever, Deccan Air, whatever airlines are available to fly between these two destinations. Then you realize, you compare and you say, oh, got it. Now Go Air is the airline that I will go by. So you start filling in your details, name, address. Obviously, you have already given the starting point, date of travel, etc. So you have almost everything filled in, your credit card information, because you are going to book a ticket using credit card. And then comes the pay button. As soon as you click the pay button, what happens is you get a message saying that, oops, sorry, the price has gone up. Now see what is happening in the background. You have already searched quite a bit of sites. You have zeroed in on a particular airline. And let's take an example that you wanted to travel from Pune to Hyderabad on, let's say, 9th October, in the morning session. So you got a fair price according to you, the 4,000 rupees, which was your budget. And then you saw that the list price was 3,500 rupees. So you picked up that particular airline, went through all the process, and you were about to pay, you got the message. Now, what was happening in the background? What was happening in the background was their data processing engines, data science engines were working. So first of all the cookies that are there on your computer, they basically see what websites you are visiting. And they ensure that you are a serious passenger and you really want to travel. Then they look at, what is in your shopping cart. They also look at what is your language preference. So these are typical cookies that create data. But basically, they are ensuring that you are a valid traveler and you are a serious traveler. The fact that you have chosen 3,500, which is the lowest price for the date and time of travel. They are now trying to take an advantage of what is known as dynamic pricing. So what they say, oops, the price has gone up and the price is now 3,800 rupees. So what has happened? The data science gave an insight that this customer is keen to buy a ticket. The strategy, business strategy, is hook him by offering a lower price and then check up the price when you are about to pay. And the outcome is the higher revenue. So now you are also willing to pay 3,800 because you anyway know that the next best price is 4,000. 3,800 is still okay. And moreover, all the effort that you have done of visiting various sites, filling in data, coming to this point, now you don't want to go back and do the same thing again because it's about a half an hour that spend on this getting this option. So you say, okay, even if it is 3,800, that's fine. So now if you really see what was available at 3,500, now they are selling it at 3,800. Straightway 300 rupees extra profit. Now, will this trick work with everybody? Probably not. Some people will be very strict. No, you said 3,500. I'm not happy. I'm going back. I don't want to travel. While some people will say, anyway, I have to travel. This is probably the best price that I want to do. But if they were to start with a price of 3,800, you might choose another airline because you may say, oh, 3,800, 4,000, not a big difference. But I know Indigo is better than Go Air as far as timing is concerned. But this is how they try and use your behavior to track you and to offer you price that is convenient to them. So not a great picture for consumer because you being tracked, nobody likes that you are being tracked. However, we are so accustomed to these kind of behaviors that we ignore them. But this is how data science uses dynamic pricing to benefit the enterprise. The third example, now we saw anomaly detection of unstructured data by video and image processing. While there is a case for anomaly detection through even structured data. Now, this is my own example. Now, I have been a serious user of Citibank card nationally, internationally. I hold this card for almost last 40 years. I have been using this card, since almost 1980. And I have been traveling across the world. So I use this card in several places, in several currencies at different time zones. Now, there was an instance when in 2014, I went to Johannesburg. At about 9 p.m., I was checking into the hotel and trying to pay the advance of roughly about $4,000 because I had an 8-day stay there. Now, as soon as I swiped my card, my transaction was declined. And I was, kind of upset because this has never happened to me on a Citibank card. I had enough credit card limit. My card was valid. My identity was valid. And I was thinking about to take out a different credit card, my HSBC card, and try and swipe that because I thought maybe there is an issue of card network. So let me try another card. I was about to take out my HSBC card. I got a call from my mobile saying that, we are calling from Citibank. We know that you are trying to swipe your card at such and such POS. POS is point of sale. That is their terminology. And this is for this and this amount. So I said, yes, but the card is declined. The transaction is declined. So the person on the other hand said, sorry, sir, sorry for the inconvenience, but we are purposefully stopped this transaction. So I obviously said, why? I am a serious user of this card. So he said two things. He said, sir, Johannesburg is a blacklisted location for credit card frauds in our database. And our database shows us that this is the card being used first time in Johannesburg using Rand currency. Rand is the local South African currency. And your data of last 25 years shows that you have never used that card or Rand currency in Johannesburg. So we thought that this is a potentially fraudulent transaction and we would like to stop it if it is a potential fraudulent transaction. I said, no, this is me. And then they just, asked the normal verification question like date of birth, mother's maiden name, etc. And he said, sir, please swipe it again. We will put it through. And that's exactly what happened. So here, if you see $4,500 of potential fraud, it was a legal transaction, so there was no issue. But if it was a fraudulent transaction, they could have avoided the loss of $4,500. To kind of tell you that the overall in the world, including all banks that issue cards, they lose $2 billion. 1 billion is 7,500 crore rupees. So roughly 15,000 crore rupees because of fraudulent transaction, either by stolen cards, unauthorized transaction, and so on and so forth. So they don't mind investing in a data science journey, which allows them to avoid these kind of frauds. Now you just imagine they had my 25 years of data, and it's not that they knew that I'm going to Johannesburg, I'm going to inform them and so on. But among so many million transactions of so many million customers over so many years, they had a way, they had an algorithm to find anomaly if they find an unusual behavior, unusual spending pattern. Now, if you really see, I have always used that card for hotel booking, airline booking, food outlets, bus shops, whatever. So from anomaly point, that was okay. I used it in different currencies, that was okay. I've used at different time zones, so that was okay. I had used it in different countries, that was okay. Different currencies was okay, except the fact that one, it is in Johannesburg, and two, it is in rand currency. So that is the kind of anomaly that they detected from all my transactions out of so many million transactions of so many million cardholders over a period of time. And that too in a fraction of a second. I swiped the card, and in about 30 seconds, I got a call. So just imagine the powerful mechanism for processing such a huge amount of data at the backdrop when I even don't know what's happening when I swipe the card. So this is the kind of power data science applications give. Now imagine, even if out of $2 billion that the credit card companies lose, even if they are able to save, let us say 20% annually, it means $400 million. $1 million is 7.5 crore rupees. So potentially, they could probably save roughly about 700,000 or 700 crore rupees out of this. So just imagine the kind of benefit that they will get by avoiding these kind of potential fraudulent transactions. Now we have seen, and I just want to recap this particular slide because the immediate next example it has a direct connection with the use case that I'm going to talk about. So we saw this slide. Just recap, take raw data, use models or algorithms to get insights, apply business context to insights, build a strategy and with the expected outcome, implement the strategy to see actual outcome, and then compare whether it is successful or not. So this is an example now. Again, it is a combination. So first we saw processing of unstructured data, in case of bank. We saw processing of structured data in case of Ola and in case of credit card. Now this is a combination. In one of the top 3 US stores, they have again CCTV cameras which are taking video films of customers entering the store. The video streaming of the film was processed using data science algorithm, and they came out with an insight which says that 85% of men entering the store take a left turn. So when you enter any store, you will have aisles on the left, you have racks on the right. But their observation, and not only observation, their insight, which is backed by data, which says 85% of the men. So if 100 men enter the store, 85% of them, that is 85, will take a left turn. So we'll go to the racks which are on the left. Now you may ask me, what is the logic? Again, same thing. There's no logic. It is only observation proven by data over millions of visits by men and women. Now this is the first insight, that 85% of men entering the store turn left from processing the video clips, which is unstructured data. Obviously, when the men complete the shopping, they obviously use either credit card or debit card, which is a structured data. Now that data gave me an insight that men who were buying products, they are not particular about expiry dates. This is the insight that data gave me. Now, how did they get this insight? Because they know the gender of the person who is paying the bill. They know what products it has bought. They know the product characteristics, that what was the product, what was the price, what was the expiry date. So their observation, or rather their insight from the data, is men buying products are not particular about expiry date. So if you are buying milk, you may pick up milk that is expiring tomorrow, or you may buy bread that is expiring day after tomorrow. While if women buy the same thing, they will look at the expiry. Mentally, they will calculate, oh, this is 5 liters of bottle. We don't consume 5 liters of milk in 2 days. So if expiry is in 2 days, I don't want to buy 5 liter. Either I will buy something which has got another 10 days to go, or I will buy 1 liter, which I am okay to consume today and tomorrow. While men are not so particular in buying, they will just pick up that bottle, put it in the cart, and move away. And I'm sure ladies and gentlemen who are on the call will agree with this observation. Although it is by and large given by data, there's no logic behind it. But these are two insights given by the store's data scientists. Now comes the business context. So you saw that you got two insights. So the business context is, the strategy person said, look, if this is the case, then let us stack products that are expiring soon on the left-hand side of the rack. So don't stack products like these are vegetables, these are groceries, these are consumables, these are FMCG. Whatever is going to expire today or tomorrow, keep it on the left-hand side of the entrance. Now, in the US particularly, keeping an expired good on the rack for sale is a crime. It's a punishable crime. You get both. You get financial penalties as well as you may get jail also. So they are very particular about throwing away the expired goods. So they can't keep expired goods on the racks for sale. But by doing this, what they could realize is, earlier, before this strategy, they had to throw a lot of perishable goods like vegetable, milk, bread, because they have expired but not sold out. While this strategy helped them to cut their wastage, and they could actually save $300 million in a year by reducing the wastage, because the products that were expiring soon are being now sold quickly and they don't have to throw away. Now, this is the power of data science, and that is why people invest in the data science exercises, data science journey. So by reducing wastage, they actually increase the profit. Now, somebody was asking me, what career the engineering graduate should take. Now, the engineering graduate will not be able to arrive with this strategy because he doesn't understand what is the consequence of this behavior or what is the meaning of this insight. He will be at best good at processing the credit card data and give me the insight, but not necessarily a data scientist who has a complete 360-degree view of the applications that are being processed, that are being used for the business benefit. The data science is also being used for sentiment analysis. One of the most popular uh, application of today's day, particularly that in the earlier days, to understand the customer preference, customer behavior, choices, a traditional method was survey. And I don't know whether you have done that, but in my old days, I used to fill a lot of surveys. So there are forms, there are multiple choices. You take, and there is some guy who comes to your door. He asks you questions. He fills in the form. He goes away, and then that form is kind of entered as a data entry exercise. It is processed, and you get the results. But this was such a time-consuming process, and by the time you get results, the results become stale. They probably would have lost their importance. With the advent of web technologies, now these forms are web-based, and I know you will also fill up the Google form for the session. But basically, you have the same methodology. Only thing is, instead of a manual form, it's a digital form. So the business of coming to you, filling the form has gone, but it is still the same. You have to process the data. Somebody has to fill in. Now imagine if you have to, fill up about 2-3 surveys every day. You wouldn't do that. You don't want to waste your time in filling up surveys. So the new mechanism is actually picking up the unstructured data through your Facebook posts, through your Instagram messages, through your WhatsApp chat, through your email, whatever is available in public domain, and process that data through your machine learning and natural language processing based algorithms to give you very quick, almost online insights which are very relevant. The most classic example is your election predictions. So whenever they are saying that this party will come into power, or this candidate will win, this candidate will lose, it's not that they are going to create these forms and ask you to put up your answers. Basically, they will look at the Facebook post and see the sentiments of people, and based on that, they will bring out their conclusions. And most of the time, these conclusions are fairly accurate. So election predictions using sentiment analysis is one of the big examples of how a sentiment analysis is used in the data science space. Now, lastly, I'm going to go through a fairly detailed step. Now, you just saw the application, but you still don't know how exactly it's happening on the background. So let me, give you a glimpse of how it happens on the background. And I'm sure throughout your course, you will understand more and more about this. But basically, this use case is about the bank applying data science to identify whether the loan that I'm going to sanction, is it going to be a good loan or a bad loan. What is meant by good loan? That the person will repay, as per the terms. And a bad loan is the person will ditch me. I will have to confiscate his asset, and probably we will make a loss. Or it becomes an NPA, non. So NPA in the banking terms is non-performing asset. That means I gave the loan, never got my money back, or never got the interest and the principal back. So the bank wants to know that if I want to reduce my NPA, the best way is to forecast whether this loan will be a good loan or a bad loan before I sanction. Now, how do I know that? Today, I take all the securities, I ask him to mortgage his house, or if it is a vehicle loan, buy the mortgage the vehicle and so on. However, if I am able to predict that whether this loan and essentially this borrower is going to be turning bad, then I will not sanction the loan. So what we are doing here is we as an exercise of data science or data scientists, we have a complete process flow of how this entire exercise is carried out. So there is a first step called exploratory data analysis, which consists of missing value imputations, outlier detections, feature engineering, feature selection, imbalance data handling. Now I'm sure you will learn all this on some day or other as part of the course. Then training and testing the module, and then actual prediction. So what we did in the exploratory analysis is we processed 30,000 loans that we had issued earlier, and we know which loans were good and which loans were bad. So this is data about the known facts. And what we did, we had all these input variables like loan amount, rate of interest, duration of loan, then borrower details in terms of age, gender, caste, creed, his salary levels, his role, whether he's an individual or a corporate or a partnership firm or a HUF and so on. So based on this input variable, my only target variable was at the end of the tenure, what happened to this loan, whether this was fully repaid as per terms or there was a problem in repayment. So whether it was a defaulter or whether it was a good loan payer. So I have this 30,000 data, 30,000 people data, 30,000 loan data with the known impact, what we call as a target variable. So we then looked at, kind of tried to slice and dice data on various parameters using, as I said, missing value imputation. So if there are any outliers in the data, we kind of moved them out. And the most important part is we applied several statistical models to arrive at what are the factors that really impact a decision of whether it's going to be a good loan or a bad loan. So for that, what we did, we took advantage of almost 6 or 7 different algorithms, because each algorithm has its merits and demerits. So for example, you will see here that we use chi-square or we use random forest as some of the algorithms. And these algorithms, all these 7 algorithms, told us that out of probably about 100 attributes of a loan. When I say attribute, it means what I referred to earlier: annual income, application type, the loan amount, the salary of the individual, rate of interest, caste, creed, age, color, area, locality, whatever. So out of those 100 attributes, the algorithms kind of gave me weightages saying that these attributes will directly impact the status of loan, either good or bad. So each algorithm, so overall, all these algorithms, and I have just taken a screenshot, there are more attributes also, but they gave me about 13 different attributes along with the weightages. So if you look at the first one, which is annual income, all the algorithms except the L1 algorithm said annual income plays an important role of whether this loan will turn good or bad. So out of the 6 algorithm that I used, 5 said annual income is the attribute to be considered. So the score was 5. So I looked at all such variables and then looked at which are the topmost that is scored by all. While if you look at the application type, only the last 2 algorithms said this is an important, while the others weighted against them. So similarly, if you look at the highest score, which is interest rate, all 6 algorithms said interest rate is one of the parameters that will decide whether it is good loan or bad loan. Now this is a common sense. Obviously, if higher interest rate is obviously likely to impact the loan repayment structure and loan repayment capacity. But that tells me that yes, look, there are logical conclusions which means my algorithms are working fine. So finally, we looked at that what are the attributes that are scoring highest. So scoring 5, 5, 4, 6, 3, 5, 3. So when I have to figure out, we will figure out first what is the most important. The most important attribute is where all 6 algorithms are telling me that this is a factor that you should consider while sanctioning the loan. So interest rate definitely one, followed by that annual income, again logical. So like that, we will look at, and when I feed this data, now let us say that I have applied for a vehicle loan of 10 lakh rupees because I want to buy a car. They will fill in all these 100 attributes of my loan, and then the algorithm will say that, look, I have trained my model by my earlier exercise of training the model using the 30,000 record that I have processed. And these 10 parameters are telling me that this is going to be a bad loan. So don't sanction loan of 10 lakh rupees to Mr. Satish Tanade. Now what bank can do? Bank can say, okay, fine, let me now reduce from 10 lakh to 8 lakhs. Will it turn out to be a good loan? Now again, my model will predict and say, oh yes, it will be now a good loan. Then bank will come back to me and say, even if you have applied for 10 lakhs, we are willing to give you only 8 lakh rupees. So this is how the use of algorithms or machine learning capabilities in data science are used in real life. And I'm sure when you actually learn more about the technology, you will get to learn more about these ML machine learning algorithms to decide, what we do in the real life. And this is now I conclude my presentation. I'm opening the session for question answer. I know we have another session to follow, but you can ask questions either through chat or you can basically unmute yourself and ask me the question.
It's Vaishali ma'am. Do you have any question? Vaishali Bambu. If anyone have any question, can unmute themselves.
So there is a point that if same strategy is applied in shopping mall, we can put menswear to the left side of the entrance. Absolutely true. Very true observation. And it is based on the first insight that men move to the left when they enter the shop. However, the real strategy on the grocery shop was to reduce wastage. Menswear is not a consumable or a perishable good, but from a sales perspective, obviously yes, because if even if they don't want to buy, if there is a good offer, they may tend to buy. But very true observation. So thank you, sir, for this observation.
Is there any other question?
So there is a question, sir. What is the difference between data science, data mining, and data analytics? Okay. So data science is an over-encompassing or overarching name for what you have mentioned otherwise. Data mining and data analytics. Data analytics, let me address that. Data analytics is the last part or the last step of where you have started. Data that is called as data mining. Data mining is nothing but picking out data from various source systems. So like I talked about, you have credit card transactions, you have loan transactions, you have saving bank transactions. So pick that data and put into a data warehouse with some common property. It's called as data mining. And then when you do that and you look at the data to find out some trend, it becomes analytics. That okay, a guy who is say saving 10,000 rupees per month is actually a very serious user of credit card because he is doing a lot of expenses on credit card and kind of saving his cash. So that becomes analytics, and then you can sell him more credit card kind of products. So that is the difference between data science, data analytics, and data mining. And it has got a direct connotation with our English. Mining is digging out. So it is exactly the same. And analytics is, let's say you mine, iron ore. That is what you mine, or you mine coal, and then you process to prepare the steel from iron ore, which is the analytics part. So there is another question. How mechanical engineers may benefit by studying machine learning? Okay. So if you really look at the applications of data science and particularly machine learning are all encompassing. And you heard in my earlier session that there are a lot of IoT devices and car manufacturers particularly, because mechanical engineering, a good branch of mechanical engineering is automobile engineering. So in today's world now, a car is 35% electronics and 65% mechanics. So if you are able to process the logs, and I give you an example of balanced life estimation, these kind of inferences are drawn by machine learning algorithms. Or you have cars which actually give you signals or logs of behavior of a driver, like whether the car driver is a rash driver, is a steady driver. These kind of inputs can potentially go to insurance companies, because if you are labeled as a rash driver, they can potentially increase the premium of your insurance. So a lot of applications even for mechanical engineers to go into data science. And there is a question by Mr. Samir Mule. How can we differentiate between data collection and data interpretation from data science point of view? So again, very similar things. See, data science, as you saw, that it's a multidisciplinary science. It encompasses or overarches all the dimensions of data. So data collection and data interpretation are two aspects of data science. Under data science umbrella, both of them will come. Data collection is a starting point. Interpretation is the part of processing. And if you are not satisfied with the answer, please reword the question. I'm okay to re-answer it, no problem. Okay, what is the exact role of a data scientist? Is it to draw inferences or to meet and convince people about the benefits of using data science, or to do programming and create algorithm for data analysis? All right, a good question, because a data scientist is really at the apex of this entire data science exercise. So he himself probably may not do all things, because given the time, one person can do only so many things. But he will tell you what kind of algorithms one should use, what kind of data inputs should go in, and when the inferences are drawn, he will also tell you what and how the strategy should be implemented. And when you say convincing about data science, it is not about convincing. He should present, and that is his key responsibility. He should present that if you apply data science, these are the use cases, they will give you this kind of benefit. So the real value from a data scientist is to identify use cases and show the benefit in a very quantified manner, because finally money is quantified. You can say, I'm going to spend $3 million. So your benefit should also not be only in English. Oh, there will be better customer loyalty, there will be huge revenue uptake. These English words do not have any meaning when you make a business case. You have to say your revenue will move from 5 million to 5.5 million, or your profit will move from $700,000 to $950,000. That is how he has to present a case. Then the decision will remain with the owners, that for this level of investment, this kind of benefit, shall I go ahead with the data science exercise that is being proposed? So did I answer your question, sir? Siddiqui sir, did I answer your question?
Hello, sir.
Yeah.
Sir, right now the Facebook, WhatsApp has introduced their new user policy, where they are accessing the more and more metadata regarding the user, where they can understand his behavior. So
Yes.
on the basis of that, they can broadcast some advertise or share some their the e-shopping data to the user.
Yes.
So, any ethics for being a data scientist or being a engineer at Facebook? Is there any ethics which data have to be used for what purpose? What is your opinion regarding it?
Right. So, first of all, when you sign up for any application, we almost give all permissions, because you don't have a choice. They don't give you a choice that, okay, out of A, B, C, D, E, you can allow me to do A, B, C, D. If you don't allow them to do everything, application will not get installed. So you have a very binary choice. Either you go with the application or you don't go with the application. And when they ask you for permission, they ask you for everything, that send you advertisements, send you notifications, send you promotional materials, use your data, sell your data, transfer your data. Now, in terms of ethics, yes, there are guidelines, but they are not at the data engineer level, because the data engineer will get specification in terms of what to do with the data. Now, why to do, when to do, that will all be decided by policymakers. And that's why I said in the first place that policymakers are also looking at data science seriously, that when WhatsApp or Instagram or Facebook or Google, if they are asking to share the data, what is it being used for? And today, the data secrecy from a national integrity and national security perspective is becoming very important. And that's why the first thing that the policymakers say that anybody who is compromising with the national security, that data is not allowed. And all the companies should tell them what data they are collecting, what algorithm they are using to encrypt, and they should also allow the governments, when demanded, to decrypt the data and see what has been carried from the individual users. So at a engineer level, at a data scientist level, these things are not really matter. They don't really matter. What matters is at the company policy level and at the government policy level. There is a question, strong statistics base is required to become data scientist. Yes, obviously the data scientist, because he has to understand statistics, he has to understand programming, he has to understand domain, he has to know statistics, because all these algorithms, right, the random forest or decision tree or chi-square, they are based on a very solid statistical foundation. Now, it is possible that you use the algorithms by moderate training. But if those algorithms are not adequate for your purpose, you should be able to come out either with a combination of algorithms, or you should be able to write your own algorithm. And therefore, a good statistics background or a strong statistic background is essential to become a data scientist. But for the other roles like data engineer, etc., it is not required, because data engineer can always call for an algorithm. So as long as you know how the algorithm operates, that is what parameters I need to send in what sequence, and then what outcome I will get, through that algorithm. As long as you know that, that is good enough. But if you have to go to the very fundamental roles, then you need a statistics background.
Thank you, sir.
Okay.
I think there is a last question.
Yeah, I'll take the last question. What are the career opportunities in data science? So there are different roles, right from a data engineer up to the data scientist or a data scientist architect. Different roles. Some of the roles are very specialized, like some people purely focus on the visualization tools. So they become really expert in tools like Google Chart, and they know exactly how Google Chart works, what kind of data feed comes in, if it is an online feed, how to process, if it is a batch feed, how to process. While some take data engineer as a role where they focus on ETL tools like Informatica, and you will probably hear more about some of the tools in the following session. So there are different roles, right from extracting data to visualizing data. You can have multiple roles in data science. So thank you for your participation.
So
Good
I have
questions.
one question. Can I ask one
Yeah.
question, please?
Yeah, please.
So I'm in a learning phase in machine learning, basically. So
Okay.
I always get confused because I can see the algorithms of there is classification, clustering, supervised, unsupervised learning, which I can see in data mining also. It is in machine learning also.
Correct.
They're in deep learning.
Correct.
So the algorithms are same, but then what is the difference? Why we can see the same algorithms in different subjects. So I actually get confused why the same algorithms are available in different subjects.
Right. So if you really ask me, it is very difficult to kind of isolate or segregate these subjects, saying that okay, this there are no thick walls, or these are not restricted channels. There is always an overlap between two streams, and therefore I see a lot of questions on that. What is the difference between data analytics and what is the difference between data mining? Because there are no concrete walls in that. Now you may say, oh, data mining also requires algorithm, while analytics also requires algorithms. So you will see algorithm, which is a very common phenomenon across entire data science stream. And that's why you have, I think, follow-up session about algorithms. because you will see that algorithm. So you can't say, oh, why algorithm is in data mining and why is it also in analytics? So very difficult to segregate each component. As far as a particular algorithm is concerned or a statistical model is concerned, depending on the purpose and depending on the use, like I said, if I'm a data engineer, I just need to know what inputs I need to give to the algorithm, what data it will return to me, and how do I use it. While if I am a data scientist, I will still need to know, but I should be able to understand the intricacies within the algorithm that is written or within the statistical model that is written. While as a user, so like, car, I know how to operate a car. That doesn't mean I can open a bonnet and maintain my car, right? But I only know that, okay, if I press accelerator, the car will move ahead. So that is my use of car. While the mechanic, he will also know how to drive a car, but he know what happens. You actually press the accelerator, what happens inside. So that is so you can't say, I also use accelerator, the maintenance guy also uses accelerator. Why is it so? So each one has his own view. And, like I said, it's like data science is like,
I'm testing my audio video.
Okay. Data science is like your story of, one elephant and seven blinds. Each one of them, looks at it and say, oh, elephant means looking like a big trunk of a tree. Who touches the trunk of an elephant? Or he says the one who touches the leg says, oh, it looks like a big log of wooden log. So that is how, the data science is getting matured. But I don't know whether I answered your question or not.
Thank you, sir. Thank you, sir. Thank you for such excellent discourse. The examples you gave, that is for fraud detection, customer behavior analysis, and dynamic pricing, were very convincing and gave a cluster clear insights. Thank you, sir.
Thank you, and my pleasure. And I welcome Mac. Hi, Mac.
Hi, Satish. How are you?
Doing good, yeah.
Good.
So you have a next session, right?
Yep.
All right. So I've already delayed by 10 minutes. I won't eat more time. People are keen to know more about algorithms. So it's up to you now.
Sorry to interrupt both of you. Thank you so much, Mr. Ranade. It was a wonderful session and participants really like it. I was observing the questionnaires and it was wonderful that participants raised so many good questions. I hope it would have continued for longer, but it would be my pleasure if I would be able to invite you to our institution so that we would have more such kind of interaction with faculty members. Thank you so much. Thank you.
Sure, sir. Thank you, Kane sir, and hope to see you sometime.
Yeah, we will definitely meet, sir. It was nice meeting you.
Bye.
Yeah.
Okay, bye.
Bye, man.
Bye, see you. Are you going to stay for my thing or are you going to run away?
It's high time to welcome Mr. Makran Gadre.
Hello.
Sir, glad to meet you virtually, in fact, but at least we can see each other online.
Yeah.
Thank you so much for accepting our invitation, and I won't be taking much time because the coordinator, Dr. Sagar Badi, is ready with his introduction. But I welcome you personally and thank you on behalf of Bajaj Institute of Technology, Wardha. And we are really fortunate that you will be interacting with the participants and the participants would be really benefited. I hope so.
I hope so too.
Let's have a great discussion and participants. Are you ready, participants? So over to Dr. Sagar Badi, the coordinator of the program.
Thank you, sir. So on behalf of Bajaj Institute of Technology, Wardha, let me have a pleasure of inviting our next eminent speaker, Mr. Makran Gadre. Mr. Makran Gadre started his software engineering career in 1985 by writing programs for civil, mechanical, and textile industries needs. In 1992, he moved to Seattle, USA, and joined Microsoft as a software engineer. During his 20-year tenure at Microsoft, he worked on various versions of Windows, starting with Windows 3.0, and many versions of Excel, Word, and Office Suite, and .NET. He has handled roles of development manager, director of development, and software architect. He was a part of a team that set up the Microsoft Hyderabad Development Center in 1999. After moving on from Microsoft, Mr. Makrand Gadre started his own software architecture and engineering consulting practice. Currently, he works with various startups in USA and India and contributes as the CTO for Hexanica Inc. and Civil Soft Systems, software architecture for CDSA, India's smart city, board of member of Cloud. We are fortunate to have him on board. Let me invite Sir to proceed with his sessions on writing algorithm for data science. Sir.
Okay, sure.
Thank you, sir.
Thank you. I worked in America for so long that nobody calls me sir, and I get lost when somebody calls me sir. So even in my companies, I told them to call me Makarand. If they find it too long, Mac is good for me. So whatever works is important. All right. So is everybody awake? It's afternoon 3 o'clock, right?
Yes.
Is everybody awake or kind of after lunchtime, chalta hai, chalne do kind of things? Okay. So this is not going to be such an exciting session, I'll tell you. Algorithms is a very serious topic, and this session, I was telling sir, keep it in the morning so people will be at least awake. But he said, no, let's keep it in the afternoon. It's boring anyway. So I said, okay. All right. So let's start. So, I don't know, is somebody, I see there are more than 50, 60, 68, something.
78, it's 78. Yeah.
Right, yeah. So, is somebody going to moderate the questions as I come in? And do you have a format here that should take the questions at the end or as they come or whatever?
As you wish, sir.
I like it more to be an interaction rather than a lecture. So
yes.
I would prefer if you interrupt me and ask me random questions in the middle. But maybe with 70 people, somebody has to moderate this. Otherwise, everybody
yes.
will just...
Okay. So we are here.
So Dr. Sagar, you are going to do that, right?
Yes.
Yeah.
All right. Okay. So that's it. So I'm going to try to attempt to share my screen now. Okay.
Yes.
And let's see how it works now. So I've got two monitors, and that's always a challenge. Sometimes always picks up the wrong monitor. All right. So present now your entire screen. Okay. Which one? Good. Can you see something?
Yes, sir.
It worked.
Good.
Yes, sir.
All right.
Same.
So can you see now? You can see my mouse moving, right?
Yes.
Can you see this now?
Yes.
All right. So I'll go into presentation mode, as they call it. All right. So we are here to, since you guys are all faculty, I believe or I understand that you are going to teach your students how to tackle the real world problems. I was looking at the syllabus for a lot of colleges in Pune. I was, for example, looking at the syllabus of the BCS and BE ComSci in Ferguson College and Symbiosis and what is the Somerset? We are say MIT, not the Boston MIT, the Pune MIT. And so I was looking at this and I found out that a lot of algorithms are considered to be taken for granted. And they have not been given the emphasis that used to happen in the early 90s when computer science actually started in the world. When I went to college, there was no computer science. So we had to just take the books and do it ourselves. But in the 80s and 90s, the computer engineering actually started. Actually, 90s, the colleges started really teaching it. And around the Y2K time frame, late part of 90s and early part of 2000, a huge amount of good emphasis was given on the algorithms. After about 2003, 2004, that went away because the web wave came. And people wanted to learn how to quickly make a website, how to quickly do this, how to quickly do that, JavaScript. All those things come into fashion. And suddenly you lose, people started losing their emphasis on the fundamental algorithms. All right. So this is how the history of the algorithms, how it has evolved. They have been there since the I think the first human on earth built fire. Algorithms have been there. So what is algorithm? There's a bunch of classical definitions of algorithms. I think of an algorithm as simply a list of documented steps to which I solve a problem. It could be as simple as going to market and getting vegetables. My steps are, is it close enough? I do a flow chart of myself. Is it close enough? Yes, I'll walk. Oh, it's a little bit far away. Is there enough place to park there? Should I take my car or scooter? These are the steps which I think about. This is exactly what algorithm is. So people have been learning algorithms like in the courses where you actually have data structures and algorithm courses. They talk about quick sort, hash search, radix sort, all those kind of interesting search algorithms, sorting algorithms. Okay, but remember that it's not always true that that one algorithm or whatever algorithms you want is going to fit your problem. Sometimes you have to do a lot of things which are a combination of multiple algorithms. Sometimes you have to tailor the algorithm, like I said. So what is the expectation? What is the requirement? And that decides what algorithm to use or what alternative algorithms to use for the same problem at hand. So when I'm teaching at some of the schools here or whenever colleges or some courses I did, first of all, if you want to solve a problem, think about it as if you don't have a computer at hand. Okay. For the people who learned Java or C#, there is no array.sort. How will you sort it? Array.sort is a standard purpose sort mechanism in C#, C, whatever. Most of the languages have it now. What does it do inside? Do I understand? Or is it a black box for me? That's what you have to think about. Because whatever they do in Java's standard sort algorithm may not be the best case algorithm for you. Because your expectations of the program are to be met. I'm talking from the industry experience here. I'm not a professor or a person who does knowledge for the sake of knowledge. A lot of times, a lot of things that are taught in the colleges are practically useless in the real life. They're never used, realistically speaking. But again, there's something that you need to know and something which end up being useful to you. And algorithms is one of the things that really gets you into very high-tech jobs. Like if you want to get hired by Microsoft, Apple, Oracle, they're going to look at this. They're not going to query how you call a Python function. They're going to ask you, do you know how the Python function works inside? Can you modify it? They're not going to ask you use a queue in Java. They say write your own concurrent queue in front of me on the whiteboard. Because we cannot afford to use library functions all the time. And that's the whole point. When you decide about algorithms, yes, there are a bunch of excellent books like Fundamental Algorithms by Donald Knuth is one of the, like our Bible of algorithms. But that tells you the classical philosophical way of doing things. And practicality, you have to always deviate from the philosophical or the classical. Not always, mostly. Okay, so I always think of it like, how will I do it if I did not have a computer at my disposal? And how will I do it if I have somebody else, like an assistant or assistants, who can do it for me? And those two things, let me think about what to do and how to do using parallel and concurrent processing. So we're going to go into this little bit more. We've got a 2-hour session. So think of it like, if I want to say, for example, take an example. I want to make a street on the street. I want to make a stall which sells vada pav. Okay. Do I know how to make vada to start with? Well, I think I know how to make vada. Fine. So, do I know how to make pav? No. I have to depend on a bakery to make pav. So, to be able to sell my product as a good vada pav, I have to know that vada is the part that I am confident in making. I don't know about the quality of the pav. Okay. So, then do I have to understand how to make pav, or do I have to start a bakery to sell vada pav? Most probably not. So, that pav algorithm is relegated algorithm. That pav is somebody making. I just make sure that guy makes the pav to my specifications, and that's my assistant. So trusted assistants is some other parts of algorithm that you don't have the requirement to do yourself, but it's a part of your product. So if vada pav is bad and the pav is bad, people don't blame the bakery. They blame the stall who sold them the vada pav. Okay, so in practicality, when you give something as you are offering, the guarantee of or the onus of fulfilling the guarantee falls to you. Okay. So there are a bunch of algorithms in machine learning, AI. Okay, by the way, machine learning and AI are the new, I always call them the new heroines of the computer industry. Okay. Blockchain was a little bit older heroine. Now they are the Deepikas and Priyankas of computer science, or this machine learning and AI. Earlier it used to be blockchain, then before that Hadoop, MapReduce, all these things, heroines went and came, and now we are looking at AI and machine learning. Okay. So as I told, machines don't do any learning by themselves. There is no artificial intelligence. I'm sure people have done courses in Python here, and you have been teaching in the field more than 5, 6, 7 years. You understand that Python, find trend, that guy finds trend. Do you know how it did it? No, I don't know how it did it. It's like I ordering to a restaurant and ordering, give me vada pav. The guy brings vada pav. You have no idea how he made it. So in case of machine learning and AI, in that kind of spectrum, you have to remember that a machine needs fundamental data points to build an inference on. For any computer, it's just a bunch of bits coming in line. To make sense of it, it doesn't do anything by itself. Some program and some underlying backing up data has been given to the computer in advance so that you think is artificial intelligence. What is computer good at, which humans are not? Doing repetitive work without getting bored. Okay. That's important. You have to remember that. Repetitive work without getting bored is the forte of computers. It is intelligent by itself? Not at all. It's a stupid machine, but it is super fast and doesn't make the same mistake again. In the sense, if it is 5 plus 3, or you ask it to total 2000 elements or 2000 numbers, human will make an error because our attention span gets lost. We lose our attention in a short time. Machines don't. And that's what you should use them for. What they can do is run through the data really fast, which a human cannot do. Because we have got our own limitations of physical movement. It doesn't have that. Okay. So remember that any AI, ML, machine learning, AI is all human driven and human assisted or human taught. You have to instruct the machine what to look for. Then the machine will look for you because it's a blind or not blind, dumb slave. It just follows your orders. So typically, one of the cases that we handled lately for one of the American banks was that a money laundering scenario. What was the scenario is that apparently a lot of money is flowing into the hands of those kind of terrorist states like ISIS and Jordan, Syria, that kind of disturbed areas. And the money is originating from typically drug countries like Venezuela, Colombia, Guatemala. So banks have stops in place. They say, oh, this origin country is Colombia and destination country is Syria. Looks like some kind of money laundering operation. So these guys started doing something else. They said the US government put a limit that any transaction about $10,000 has to be reported. Okay. These guys started making hundreds of transactions which are $7,000. So it's like typically like India. Remember, sometimes if you want to give your PAN card beyond 50,000 rupees, you make 2 transactions of 25,000 rupees. Something similar. So at that point, we did not know what to catch for. But then the specialist told us, okay, look for the transactions from the same account, either origination or destination. And but bunch of how many transactions of less than 10,000 this guy have happened. And then we found out, yes, there are particular bank accounts. They keep on getting these small amounts, hundreds of small amounts. And they end up being totaling to $1 million. But they're never caught because they fly under the radar. So that's what we taught the machine, that, okay, look for the same machine. So tell me how many transactions it passed out of total transactions for this account. How many transactions were less than 10,000 and more than 5,000. And that gave us a different picture. But the machine did not reference it by itself. We had to tell it 5,000 and 10,000 limits. Then we did that, told the machine to, okay, now find all the transactions and give me a standard deviation out of it. And then we could figure out that, okay, anything beyond this particular, say, 1.7 standard deviation or minus 1.7 standard deviation, whatever that is, oh, these are supposed to be suspicious accounts. Okay. Who came up with 5,000 and 10,000? Some common sense. And common sense machines don't have. Okay. So let's go on to this one. So standard libraries, like I said here, they have bunch of beautifully written algorithms for standard things that, like, it's like a standard screwdriver or standard hammer that you buy from the store. But many times you have to tweak that hammer to make exactly fitting. So the hammer that you buy in the market cannot be used for tuning a tabla, for example. A tabla hammer is slightly different. Okay. Or there is a small that goes up and down. That's another hammer. But so Python algorithm, Java algorithm, C# algorithms, they are all standard hammers, standard screwdrivers. Okay. You have to know how to use them and you have to know how to modify them. Okay. Like I put it here, you need to know them like a friend. Okay. But you have to think through them. So let's look at some interesting examples here. Okay, I'm going to ask you this question. I put some prominent Indian people here. Okay, please order them. How are you going to order them? Anyone answer? Because I cannot see the screen now because I'm presenting, right?
Either alphabetically.
Okay, why?
I think that is easier one.
Okay, first name or last name?
First name.
Okay. I'm going to put their birth dates here. Now, with this new data, you're going to say, oh, you know what? It makes sense to arrange them by birth date.
The numbers are easy to handle.
I don't know. So, there is not one answer to this question. Now, think of it. When you did this ordering in your mind, without the advantage of having their birth dates, you said, let's do it by name, alphabetical order. Okay. But then as soon as the new data came into picture, you said, maybe it makes sense to do it by birth date. Now think of it, this is the list of employees in a company. They have their first names, last names. Then they have their birth dates. Then their date of joining, their salary. Now you have 4 or 5 different ways to order the same data. How are you going to do it yourself? No, I'll tell SQL Server to do it. So, do your students are going to understand that this same data is going to be displayable in 4 different orders depending upon the key of the sort. Now imagine if this data is Government of India's Aadhaar card data, which has got how many? What is our population now? 1.5 crore, whatever that is, 1 crore entries in that. So 1 crore entries, are you going to sort them physically on the hard disk in a SQL server? If I want to say order by birth date, order by what do you call it, first name, last name, order by PIN code, order by what state he lives in or she lives in. No, this is a problem, right? I'm sure Dr. Nilekan has solved it. I'm sure they have multiple indexes to the same Aadhaar card table. So this is one where we have to think that one size doesn't fit all. The standard algorithms for ordering, no, I don't want to order now. I just want to build the index of that. I cannot be sorting them anymore. They can come in the order, the way they were entered. This is the order I entered them. So look, Indira Gandhi ke baad, there's Rajiv Gandhi after that, who is much younger than Rabindranath Tagore for sure. Okay, so think about it. This ordering is one excellent algorithm. So now we say, we know all these sorting algorithms. Tell me some. Bubble sort is the easiest one. Insertion sort. What else? Shell sort, merge sort, quick sort. Which one is good? Anybody can answer? Can anybody answer here? Which sort is the best sort? Because this is the question a Microsoft interviewer will ask, or a Apple interviewer will ask your students, which sort is the best? And I think as a faculty, you have to teach them. I think that will be a good way to say that, you know what, understand the sorts. And for some things, quick sort is good. For some things, insertion sort is better. For some things, the stupid bubble sort works fine. Depends on data size. So what are the things that you think about when you do this ordering? Well, we will come back to that in another slide. But what is the constraints on my sorting? So if you think of any, I don't know if anybody, all of you guys are, I think, anybody use punch cards in Fortran and COBOL in 1980s? If somebody has, then you will notice that the punch cards, the data used to be on cards. And they used to go only in one line. You could not do random access. It was always a serial access. Card 1 to card 20. They always go in the same order. And there is not enough memory to store everybody's data and sort them. So what do? You pick 2 piles. Like little child, when you're playing cards, and if you tell little child to sort them, king, queen, ace, 10, 9, 8, the way they do it by hand, that's what we had to do. So for that, quick sort was impossible. You could not even do it because there was no way to randomly access data. So for that scenario, only insertion sort worked, nothing else. Quick sort works great when when you have a lot of memory. If you're running out of memory, have you heard of page faults in the so on a processor level, right? The L2 cache of a processor always caches some data pages in memory. So your quicksort typically, you know, quicksort algorithm, right? It starts from one end, other end, you find this point where all the elements to the left of the point are smaller, to the right of the point are bigger. And you say, okay, recurse into this algorithm. Now do the same thing for the left piece, same thing for the right piece. And again, go until you get a piece of size 2, in which you know exactly there are only 2 and this is sorted. You just put them together again. That's how quicksort works. But quicksort, while doing this, it requires the first element and last element at the same time, because it is going to go one pointer from the right side, one from the left, and trying to meet in the middle. So if you're memory constrained, quicksort will actually be slower than bubble sort, because your processor will trying to say, I want the last element, I want the first element. So it's going to hit your hard disk or your actually swap file. A virtual memory will run out. It will do this thing forever, and actually you will find out, array, it would have been easier if I had done it one line, because I would not get page fault. So again, quicksort is good. Because memory is 100, you got enough memory, quicksort is beautiful. Lovely. If you have less memory, no, let's not do it. I want to see something more. So here, I'm going to show you some random pictures and tell me associations of it. It's going to go one by one. Try to recognize the pictures. Hopefully you will, anybody would recognize most of them. I think this is done, yes. So, did you recognize all the images? Most of us did.
Yes.
All of them you recognized, right? How did you recognize them?
Based on
Based on you can see it, and you have a database in your brain to relate this particular pattern to Flag of America. Though it is twisted, you know that this is Bhimsen Joshi. You know this is a picture of a golden retriever dog. You know this is the map of India, even though it is inclined by certain degrees. You know this is some kind of SUV. This is a Egyptian pyramid and the Sphinx in front of it, Statue of Liberty, 1 rupee old note backward. Do you imagine the kind of image processing your brain did in those milliseconds, microseconds? So your brain has got this entire database into itself. You don't have to refer to anything. I took the images which are very common here. Did you refer to anything in your mind? Nothing. Now can you find this process? Write it down as a part of algorithm. What did I do? So let's look at this simple one. Let's look at this picture of India, of map of India. As soon as you saw it, you saw a picture, and you said, oh, it looks like a square. It looks like a square. So I should, in my mind, rotate it certain degrees to make it vertical. So you saw it vertically now in your mind. Then you said, okay, what does this shape correspond to? And in the moment, it didn't ever take a microsecond for you to understand its map of India. If this was map of Austria, would you have found it? If this was a map of some random country, Romania, Chile maybe is easy, it's very long. Brazil is also okay. But one of the countries like Botswana, is it a map of Botswana? Would you have known? No. So what did your machine learning do? Your brain was a machine. It learned on the data that it already knew, and only on the data it already knew. There are all the examples of data that you already know. Even though you have not had this particular dog, you know that it's a dog. It could have been a German Shepherd here or a, any kind of Irish setter here. All dogs would have been identified as a dog. This one, is a Pepsi logo. This is Bhimsen Joshi. I'm sure if I had put his younger picture, you would have still recognized it. Now look at the way. So this is the algorithm. Have you thought of the algorithm that we did just now? And the key to teaching algorithms or learning algorithm is breaking down the steps I took in my mind to analyze this picture. So I told you, basically I turned the image this way, and then I recognized from my library in my mind that this kind of picture which has got this kind of shape. Now look at this. This is so complicated. Can you write a program to do this? Wow. That's going to be the challenge. And that's why your machine comes handy, because without getting bored, it can look at millions of pictures which kind of look like this. But you have to supply the pictures to start with to identify it. So there is no machine learning without machine teaching. We teach the machine, give it enough images. So there are ways to vectorize the images. I'm sure there are a huge amount of Fourier series transformations and high-end mathematics that goes into it. And they come up with a fingerprint for the image, and then they try to see it if the fingerprint kind of matches. And then, so if I was to upload any one of these images, most probably to one of those image finder sites, they would find it. Maybe not Bhimsen Joshi, but I'm sure maybe not this car, but they'll certainly find phone. They will find out. I think they'll find most Statue of Liberty. Sure, it's famous. But will they find a Vallabhbhai Patel's new statue? Most probably not. They don't know about it. Okay, so this is one of the areas where artificial intelligence looks like astounding to you. Actually, it's not at all surprising. It's just super fast, and it can look at those millions of images without getting bored. That you would get bored. If I showed you 150 photographs of, actually 150, how many countries are there in the world? 190 something, right? So those 90, everybody's map. If I drew like this and gave you a piece of, give you a book with that and said, okay, now figure out what map is this. You'll start looking one by one. And then after some time, you'll get bored, I forget it. The computer doesn't get bored. It can also do parallelizing, in the sense it will say, okay, in one thread, I'll look at the first 50 flags. Second thread, I'll look at the next 50 flags. Anybody who finds first is the winner. That's when your concurrency and parallel programming come into picture. That we cannot do. I cannot suddenly make a clone of myself and start looking at half the book. Okay, so you need to use those algorithms to slice and dice the data vertically, horizontally, the way you want them to. Let's look at one more. So this becomes unstructured data. This is unstructured. I have no idea. I could have written some text in this. Who is stopping me from making a photo of a road sign or something? This is completely unstructured data. And to be able to learn this, you have to quantify the image into a formula or some kind of a Fourier transform or some kind of a fingerprint. Anybody here use Shazam? Have you used Shazam app? The one that identifies music. Excellent piece of work. Whosoever did it, hats off. That takes your sound waves, converts them to Fourier series. That's the algorithm they use. From the Fourier series, they come up with the general Fourier equation. And now they've got a database of, I don't know how many millions of songs that they go into there and, oh, that matches. That's Lata Mangeshkar or whatever, Kishore Kumar singing this song. So what is the algorithm? convert that database, convert that image into a Fourier transform. Remove the noise, change the amplitude. Okay, how do you so if you sing a song which is similar to Kishore Kumar, it will not find it. Of course, you will not sing it as well as Kishore Kumar anyway. But if you sing it, even if you manage to sing it, it's going to be slightly different in the equation. It's not going to say it is the same song. Try it on Shazam, sing your own song and play a Lata Mangeshkar song. It will find Lata Mangeshkar song because this machine has been taught to look for it, not because it knows intuitively. Okay. One of the biggest issues in machine learning are the pattern matching. Now I'm going to put patterns here, and please tell me what are the patterns. What is the first pattern? Can you tell me what this could be?
Aadhaar card number.
It looks like credit card number to me. Credit card or debit card number. Does it look like that to you? What are the other possibilities here? Not too many for this one. How about this one? What is this?
Aadhaar card.
Looks like Aadhaar card. Fair enough. What is this?
PAN card.
PAN card number.
What is this?
Vehicle number.
Scooter or car number. What is this? Now this is interesting. What is this?
Maybe date.
Okay, date. Is it this date or this date?
Yeah, why?
Yeah, both.
There is a different number of formats.
Right?
The format is different.
No, I'm looking at a third one. Third one, is it this where my mouse is moving or is it the last one? They look the same to me. Here machine cannot distinguish. Is it 2012, December 18 or is it 20 December 2018? So how will you find? Now let's write an algorithm. If I get this string, I have to figure out what it is. Algorithm to match my pattern. What would be the algorithm here?
Month cannot go beyond 12. Month can be in the range of 1 to 12 only.
Why? Sorry, I didn't understand. Can you say that,
Month,
please?
month can be in the range of 1 to 12 only. It cannot go beyond.
Unless it's a Hebrew calendar where they have 13th month or Indian calendar in Adhik Mas, there can be a 13th month.
Yeah.
Okay,
That
fine.
is
Let's just stick to Gregorian. Fine. Okay. So 12 is a month, right?
Yes.
So you're sure that this is going to be a month, right? Let me open Notepad and I'll give you a confusing example here. Format, font, which is, let's make a big font so I can see everything on the screen. Okay, whatever this is. This is my example. Now this is confusing. What the hell is it? Any one of them can be date, month, or a year.
Yes.
So can this pattern be solved by a computer? By itself? No. Other two are pretty straightforward. We can tell 20, so we know that it cannot be a month for sure. This is 12. So it could be a month or a date, but now since this cannot be a month, this must be a month because this is 4-digit. Here it is very clear, same way. Here it is not so clear, and this is completely ambiguous. So what is the algorithm to find this one? This one, okay, that's the hard one. Let's look at the first one. I just throw a string at your program. You're supposed to tell me what it is. How will you do it? One idea comes to mind. Just use regex. Just put the damn thing in regex and find out if there are 4 numbers followed by a dash, another 4 numbers followed by a dash, another 4 numbers, and that should be my MasterCard Visa number. Okay, so I write the regex by whatever that \n*4, whatever the syntax of regex is. Then I say, okay, next regex is this for Aadhaar card. This is for, so I say 5 characters followed by 4 numbers followed by a character is India PAN card. Then I do similarly for, these are good patterns. This is a bad pattern. This is a bad pattern, really bad pattern. And now some unknown formats. What is this format? What is this format? You don't know, right? Because you're not exposed to it. This is America's version of social, this is America's Aadhaar card number, which is their social security number. It looks like this always. So for an American person, this is very clear it's a social security number. For an Indian, this is clear it's the Aadhaar number or this is a PAN card number. But for machine, they're both weird strings. Now imagine you're getting 1 million lines of this kind of data and you're supposed to find out, like you get a huge table and you say, oh, tell me, find out what it is. Now you got a problem. You cannot expect to run regex on every one of this because regex by itself is an order n operation. You guys are all, you know this order n. Regex by itself is going to be order n operation. And for every string order n, that means you're looking n square. So what would I do in this kind of thing? So we use something called as a elimination algorithm. So we look at the first character only. Then we have a kind of a tree, which I'm going to write here. So if I look at my tree is, first character is a number. Okay. Then my possibilities are, first character is a character C. I look at this, first character is a number. So in my, I just jump from n to possibility choices are now 1, 2. These 2 went out of my even search pattern. So this word is called as a try block. It's not TRY catch, TRI. Or there's some other name for it that these people who have forgot. But I call it try. So you call first character and you say, okay, this character is a number. That means I can be only this. If it is a character, then I can only be PAN or vehicle number. Then I got regex for PAN. Then I go the second character. Third character. I keep on narrowing off. First 2, 3, nothing happens in this. Third it happens. You suddenly get, so my number, incoming number is, let's say this. Fourth character, my pattern says, if it's a fourth character, third character is a slash. So these 2 go down. These 2 immediately go off my search. So I start traversing then. So it is an order n algorithm, but it has got a very high chance to fail quickly. So it will eliminate my, so you see in the regex you have to, otherwise I would have compared all strings one by one, right? And found out that, oh, this one matched, so this is my number. Here we say, don't do the second order n until you are sure it's going to pass or it at least looks similar. So what you do is you look at first, then second, then third. Third you say, oh, this is a slash. So this is not, this cannot be this date or this date. So 2 more went down. So only candidates remain in this. Fourth dash, we're still okay. Fifth dash, you're still okay. 6 dash, 7 dash. Okay, this guy goes out. Right? Actually, earlier this, even the 4th dash, even this guy went out. So you're remaining with 2. Then you start going until you hit. And most early, typically, you'll get 1 or 2 patterns that hit it. And this becomes then a, instead of multiple regex PAN matches, in one regex match you get the answer. One algorithm that looks like this. Can I do it in parallel? Sure, why not? I'm going to give the same string. If I just have to identify the strings, I'll start 10 different threads. or 100 to order, depending on my machine configuration. I'll say, okay, you take first 100, you take next 100, or first million, let's say 4 million records we have. You guys take first million, second million, third million, 4 million to the same algorithm. Or I could say something like this. You start with M, character, you thread, you take people, you worry about the guy. This looks like a one of those which start with a character. Go figure it out. It doesn't start with numbers, so I'm not even going to give it to you. There is a delegator at the top. So many different algorithms are possible here. Regex is one, straightforward match is another one. Third one is like I said, look at the first, look at the last, look at the length of the string first. If it is 1, 2, 3, 4, how many is 16, 17? If it is 19, then all the others are gone immediately. That could be the first level optimization. First look at the length of the string. It is 19. That means all the other guys don't even have to check. So that's you develop the algorithm, but it's never a standard algorithm. Like I told you, regex is a standard algorithm. String search is a standard algorithm. But my algorithm says I use these pieces, these standard pieces of mathematics to make my algorithm for this pattern match. Then I measure it. Measure it. For the data set, it's supposed to run on. Not on my test data set, because my test data set is always 200, 300 entries. My real data set. Then I see, you know what? This was really slow. Because I did most of the data I seem to get is credit card numbers. Let me check that up in the front. So you keep on tweaking the algorithm. You keep on changing the order of this lookup strings for whatever you want. And then be ready to change it if new data comes in. So algorithm is never 100% complete ever. It's ever changing. You just tailor it to the use case you want to nail down. It's a bank use case of billion records. Yes, you want to really think hard because turnover time expected is, I don't know, in 15 minutes. Can you crunch billion records in 15 minutes? One gig, not 1 gig, 1 gig, 1 billion record, there's 6 to 8 gig of memory. And you'll say, you know what, I'm going to put 10 processors. I'm going to use parallel processing. I'm going to slice and dice the data. For some operations, you cannot even do that. Some operations, you require all the data in one shot. For example, statistical operation like median or quartile, percentile. You cannot do that in multiple cases. So all the algorithms, so there's the algorithm called as median sub median. So never decide the algorithm, I'll do quick sort. No. I'll do a sort. I'll measure and see which one to use or a hybrid to use. So one of the codes that I wrote in .NET long time back was, I believe, was it a binary, some kind of search it was. So actually we said, you know what, this is really stupid. There are 10 elements. Setting up a hash search is really stupid. Even linear search is equally fast. So there is a code in that it says, oh, your data is only so small. Forget all these fancy algorithms. I'm just going to do a straightforward linear search. We have only 4 entries. As it starts going beyond certain thing, and it says, you know what, you're getting bigger data. I'm going to start using binary searching now from inside, within inside. You don't even know that it's doing that inside. But again, this was tailored to suit some, you know, these computer magazines, you know, that computer magazines, they write the reviews. How fast is Windows in, or they compare whatever, IBM Solaris or BSD Unix. In those days, Linux did not exist. So we used to compare ourselves with Solaris or Unix or what was the other one that they had those days? OS2. Yeah, we used to compare with them. So to beat the benchmarks, we had this kind of algorithms inside. That was how it was done. Now let's look at the next one. Now this is very interesting. So we did this, we did this, we did this. My animation also happened. How can I just do? Can I just do a page down? No. Okay. This we did. Pattern matching, one of the biggest areas of AI and ML. And if you put this, you tell the algorithm what to look for, it will find it to you beautifully because it's not bored at looking at 1 billion values. Okay. Okay. Now here, I want you to read all these things. 4 or 5 sentences here. Did you understand all of them? If you don't understand, fine. Am I audible or am I lost or something? No, I cannot hear anything now.
So you're audible.
Oh, okay. Because I thought I lost my connection.
Audible, sir. No, sir.
Okay, you read all this thing. You understood most of it, right? All of
Yes,
it, pretty much. Now look at this. Did you notice that there were spelling mistakes in here?
Yes.
Then why did you say it was right? Supervisor spelling is wrong. Transaction spelling is wrong. The wrong principal spelling is not wrong, but it should be principal, not principal.
Yes.
And of course, New York I spelled as New York. This was a clear spelling mistake. But did you think that, did you know it was New York or not? You knew it was New York. Because there is no other town called as Few York or New York. Even this, your brain, supervisor, V and I were interposed, your brain didn't even take a microsecond to figure out, oh, it must be supervisor. Transaction, same thing. And this one took a little bit of thinking, or even for the, oh, it should be principal, but I get the, so think of it this way, your brain is so advanced in semantic matching. Now, can you let the computer do this? If I ask this question to a computer, where is the supervisor's office? Will it figure out that the person, the question actually is not supervisor, it's supervisor, and give me the correct answer? Now, what's the algorithm here? Think about algorithm. Think about an algorithm. How will you fix this? Are you going to be able to change the data as they type? What are you going to do? What are you going to do? Forget as they type. Can you make sense of it? We can make sense of it right now. This is where your algorithmic thinking comes into picture. Here, what I would do is I'll use that Levenstein distance. That's an algorithm which tells you from the, so basically all these characters are there, right? So I have to have a dictionary up at the back saying that there is a word called a supervisor. Okay. So my dictionary, I got a huge dictionary where I say I've got a word called a supervisor, which kind of, but how do I know it looks close to it? So I look at the character. I've got 2 S's, 1 U. Look at all the characters who had this. Okay, I got this 6, 7 words. Now see how far they are from this. And this looks like this off by only 1. So there are 2 replacements to be, or 1 replacement to 1 exchange to be done. And this will be correct word. So that I can say, oh, it looks like supervisor. So will you use Levenstein distance here? What will you use here? And these are the real life problems which come to us in the field. Short forms is another one. RBI. Everybody knows the Reserve Bank of India. How does the computer know? Your one transaction says deposit into Reserve Bank of India. Other says received from RBI. Oh, they're the same bloody company. Now this becomes very interesting. And this is one of the biggest area of natural language processing is this. Alternate spelling. In the American world, Robert, Bob, Robbie are all the same person. The short forms of the same person. Now this is my daughter's name in various ways written in India. Last one is Thai, by the way. Anybody read Telugu or Malayalam here? Because this is Malayalam. According to, I just took it from one of the, I just said Amruta and show me in Malayalam. I copy pasted. I cannot read this myself. But again, look at this. When my daughter was studying in Hyderabad, they would put her name as Amruta. The typical South Indian way of writing it. In Delhi, people write Amrita. Marathi would write it Amruta. And now it had a confusion on the passport all the time. Because, and of course, it's in Devanagari, it's Amruta like this. So on her passport, she was actually stopped 3 or 4 times at different airports. Because what is your name? Amruta. But it says Amruta here because some Hyderabad ID called it AMRUTHA. And the passport same AMRUTA because we took it in Pune. And the visa, Canadian visa said AMRITA because some North Indian people typed it. And this is the worst when it comes to money. Can I write my check in English? Devanagari. I believe this is Malayalam. I don't know what this is. One of them is Telugu. This is Arabic. This is Roman CX. Well, nobody will write like this. But if you look at the old English documents, there are some numbers written actually like this, CXXX. Now, if I want to get this data into my computer stream and if I want to do totals, if I am actually working in Saudi, I'll get numbers in this format. Where my mouse is moving. We call them Arabic digits. They call these Hindi digits. Do you know that? They call it Hindi digits. Because they got them from India. So they call it Hindi digits. If you look at that, is our digits only twisted right way. Since 1 is like 1. If you turn your head to the right 90 degrees, you look like 3, 2, and 1. Okay. So the shape changed over the years. Even the Roman Latin digits, very similar to Sanskrit. 4 Dravidian languages did their own thing. Arab, Middle East took it from India, so they look the same. And then this is completely Roman way. They didn't count beyond 1,000. So now, if I get a number like this, will you be able to add? Does this make sense to you? Like, if I go here and say 1, 2, 3 plus 30. What is the answer? I know the answer is 153 or 153. Which is correct? Both are correct. So here was the algorithm. We get rid of this monkey. How do I go back to? Can I say start slideshow from here? It used to be there, right? Everybody know?
Yes. Yes, sir. Yes. So you can shift F5.
Shift F5. I forgot that. I did not work too much on PowerPoint. That's why. This PowerPoint thing is a big mystery to me. Huh? No, I worked on Excel a lot. Right from Excel's first version of Excel 90, not 95, before that. Excel for Windows and Mac. Excel, what was Excel 4? I worked on Excel a lot. I worked on Word somewhat. I worked a lot on Windows internals, and then I worked a lot on .NET internals. I wrote a Java compiler, by the way, when Microsoft was fighting Sun in the court. So Microsoft had to make their own Java compiler. So we wrote a Java compiler. And all JDK around .NET. Okay, those were the days. Okay, here we come to the part where we say, so our algorithm considerations are these. How much time, how much space do I take? What are the bottlenecks? Bottlenecks, that means, what are the parts of my algorithm? They have to go in one line. Okay. What can I do? I hope you understand the difference between parallelizing and concurrency. They're slightly different, but same idea, but slightly different. Should I explain it a little bit here? I think you should tell your students about this. So if my program is doing multi-threading, it's parallelizing. if my program is essentially spawning off multiple copies of itself with concurrency. So think of it. Think of if you have you gone to nowadays COVID, nobody goes out everywhere. But if you used to go to a railway booking office before, in the old days when it was actually physical, so you could go in that thing, and there were like bunch of counters in the front. You take a number, and when your number gets called, you see on that thing number, window number 16. You go to window number 16. That's concurrency. 16 windows are running at the same time. Okay. Within that window, however, some parallelization happens, which is you give the ticket number, then this guy says, okay, would starts printing the ticket and takes the money from you. So one thread is printing the ticket while he's taking the money from you. That's parallelizing. So typically what I say it as, and actually there are people who don't agree with me, but you know what, that's why disagreement is the best way to have discussions. So I think this is what I call parallelizing. Caching. Caching is another area where huge amount of work can happen, and it can also be a source of tremendous amount of bugs. Caching is persisting in old state. So whenever I say there is nothing like real, so let me go a little bit digress here. What do you think is a real time? Real time calculation. Some people say, oh, it's a real time data, so whatever, real time computation. What does that mean? Can anybody answer it? What is real time? You guys have been quiet, or maybe I'm just talking to nobody, huh? Is my mic actually on? I guess I don't hear any feedback here. So I cannot even hear noise or people, at least, sometimes I hear people breathing or sneezing or something. I don't even see that. It's very
Sir,
quiet.
all mics are mute.
Oh, that's why. Okay, no wonder. Never mind. Fine. So, because I cannot see that now, because I'm showing this PowerPoint thing. Anyway.
Yes, sir. Yes.
Right. So concurrency, caching, dependencies, what do you depend upon? And all these things have to be considered before you decide on an algorithm for a particular industry, particular use case. And as soon as you decide the algorithm, you start at step one. Let me reevaluate it. Can I do better than that? How did it fail in the market? Or maybe it did not fail in the market, but it's not the most optimal way of doing things. Bottlenecks is one, caching is another one. So I asked a question, what is real time? Anybody answer?
So actually we are also putting something in the chat box.
So I should start looking at this. Stop this presentation. I don't have too many slides remaining. Actually, I've got a case study. So there the chat box में question, there are questions in chat box. So where is it now? Oh God. Morning I was doing this Zoom, and then after some time Microsoft Teams. So I forgot. Where is the chat box here? Yes.
Sir, on the right top side.
Yeah, I got it. Right. So okay, this is good. Maybe I should make this PowerPoint small and look at this window. That's also not a bad idea. All right. Good. So what I'm saying is that the real time, there is nothing like real time. Okay, the only thing I have really seen a case of real time transaction. If you look at a transaction, what is a real time transaction? Before it's persisted, it's sitting only in memory. It is not persisted anywhere, and it can change. Okay. Think about it. If I do let's take an example of share market trading. Okay. So you place an order, or say buy 100 shares of Microsoft at whatever $200 each. So as soon as you enter the order, your broker says, I'm going to give real-time processing to you. That's not true, because your 200 order was saved somewhere. At that time, it became history. It could be a 1 millisecond history, but it's still history. Okay. Remember that is real time is when you started the order and before it was written to the database that Makaran gave order of 100 shares by Microsoft. Between that time was the real time. After that time, it went into a system, it was recorded, became history. So history could be 7-year-old history or 7 microsecond old history. History is history. So whenever somebody says, I do real-time processing, first of all, you should tell them, don't lie. No, nobody does real-time processing. You only do processing which is so fast that you feel it's real-time. By definition, everything gets persisted at that time, history gets created. So remember that. Never claim to people that we are doing real-time because you are not doing real-time. You're doing very quickly, but not real time. Okay? And then you come to dependencies. Dependency is the worst part. I depend on this third-party web service, I've got a web app, and then I have to show Google Maps on that little window when the Swiggy is delivering my food or something. That guy, that motorcycle, it says that he's gone here. Or your Uber or taxi is close to you. Now they've got a huge dependency on this map provider, see? If that map provider is not responding well, their application is not responding. So what's their plan? What happens if Google Map or they use MapQuest or whatever that is, if that stops working, what do? You can sometimes see a blank little white square there. Your Uber is not arriving and you don't know where it is. Right? Or sometimes they have something. There is like if you look at which one was that good one I saw, the other one. I think it was in, this guy, what's his name? Dunzo guy, you have seen Dunzo guy? Dunzo is a good app. Apparently you can tell somebody to buy something from you. So you can tell him that go to this place, buy this for me, go to that other place and buy, I don't know, tomato for me, go to this place, buy electric bulb for me, bring it to my home. And he charges, it's like a, what you call it, as a courier for you, but he runs around and does things for you. There's a similar app in America for that, I forgot the name. And that app, they do the same thing. And that app, it actually, when the data goes down or their maps cannot, it says, from the predicted value, this guy could be in this vicinity and they show static map. So they have taken care of the dependency well, very well. Apna Swiggy wala kuch nahi karta. Swiggy wala blank dikhata hai kabhi kabhi. Okay. So caching is one more thing I talked about. Caching is when you persist some data, so you don't want to call it again and again. A typical example is somebody logs into your site. You have given it a session to him. You issue a session, and that guy is doing certain things for you. How many times do you validate the session? Theoretically, every transaction you should validate the session. But a lot of people say, oh, that's too expensive because you have to go validate the session, up the session, all those things are expensive. So we do it every 100 transactions, or we do it every 5 minutes or something. So in 5 minutes, if that guy or that person who is your employee gets fired, next he gets fired in the first minute, next 4 minutes he has unauthorized access to your system. That becomes a security hole then. By caching credentials, never do that. Actually, you can do that during a session kind of, but every time you have to make sure you're not doing something drastically stupid. Okay, after that, I'm going to take a little bit of break. I have to go to have a nature break and drink some water and back in 2 minutes. So I think you're also hoping to stretch your legs for 2 minutes. I'll be back in 2 minutes and then we'll go to 2 case studies and then we'll take questions.
Yes, sir. Yes. Thank you.
Okay. Give me 2 minutes.
So I request all the participants to be present in the meeting itself. Sir will be back in 2 minutes. Thank you.
Hey, I'm back. Oh, are we all back?
Yes, sir. Yes, sir. We are there.
Okay. So let's start with the next one. You can see my screen, right? So which is kind of good. So I don't have to do this full screen nonsense. All right, so we did this, didn't we? So let's look at a quick case study. And I want people to type in their answers, please, because I cannot see. There is a frequent, everybody understand SQL here, right? Pretty much.
Yes.
Read this. This is a data fetch cache we want. So this simple SQL statement, typically bank, so you're logging on from your mobile phone or you're logging on from website. And typically the query comes, select account number, account name, current balance from accounts, and join with that, join with this, join with address table, join I don't know what, where date ranges between so and so, etc., etc. Account number is so and so, that kind of thing. Okay. So what is the caching mechanism here? Because this query is going to happen hundreds of times, let's assume, from your particular business scenario for the same accounts, same conditions again and again. Of course, querying a SQL server which is in a different location is very slow because it depends on the speed of your network. So I've seen a lot of people do this query hundreds of times in the code. How will you cache the result of this query is the case study. Give me some answers, then I'll tell my view on it. And nobody's view is perfect. I'm no smarter than you are. Everybody will come up and then finally we will decide one. And think of this, this is what we need to teach the students today. If they want to get job in top 20 software companies, they don't care if you know CS and PHP well. They care if you understand this well. A lot of people are happy using libraries without understanding what they do. And that's one of the biggest failures is that, oh, it's done slow, put a faster machine. The problem is still there, but I just hid it by putting a faster machine. So anybody has got any ideas on this? Please say something, guys. Hello? Anyone home?
Excuse me, sir, we are, I'm not getting what we are supposed to.
No, just give an idea. You're supposed to not make this query again and again. Just store the result of the query, and you avoid making this query because every time you make a query, it takes 3 seconds to come back.
Okay.
In your program, you're going to make this query for hundreds of users, multiple times. Every time you make a query, it costs you 2 to 3 seconds. And you've got 1,000 users.
Sir, can we create materialized views?
What, sorry?
Can we create a view for this kind of query?
But again, this is the query. View or query is the same thing. You're hitting the database, right?
Can we write cursors to fetch and store the data?
Correct. That's again, at what level are you doing it? Again, you're putting the load on the database. You still have to go and hit the cursor. Your transport is slow here. You're sitting here, the database is sitting in America. Your transport is 3 seconds for every query, 2 seconds. Even if you put cursors, or even if you put stored procedures, even if you put something like what you said earlier.
Views.
Views, yes. You're going to have to still go to the server and bring the information, right? I want to avoid going to the server at all. This is actually a realistic scenario.
I think.
Okay, Amol Zumde says, let's catch the tables. Okay, Amol says, catch the tables. Okay, somebody says, in that case, you have to load data individually. Yes, correct. You have to load it for. Let's give a more concrete thing to this. We have got 1 million accounts, so let's say 1 million is too big. We've got 100 accounts here, and every query takes 1 second. So we are looking at populating a table of 100 seconds delay every time you make a query for 1 second for every user.
Can we use a JSON data format?
Sorry? No, that's a transport format. JSON XML doesn't matter. It's going to have to flow through wire. Now think about it. See, this is the problem is that I'm going to have to make these queries everything. Correct? Again, Prasad, Pramod, you are saying cloud computing helps users Samba. What is Samba? Have you used Samba? No, Samba doesn't help in this. Samba is an Active Directory Samba is a mechanism to authenticate between two different disparate systems. Samba doesn't help here. What helps here is that your algorithm in your program. What you do is, in this scenario, one idea that comes to my mind, not that I've solved this problem myself, this exact problem, something similar I may have solved. I would say, okay, you know what, my queries always select account corner, will my multiple joins is just a query. Where clause is the one that I specify from my user side, which is I'm highlighting here. Most probably it is going to be where date between whatever and account number equal to 1, 2, 3, 4, 5, 6, whatever. Something like this. So this query of mine is constant. This part never changes. I will remove the multiple joins also here. Okay? Something. Then I say, okay, how many do I have? 100, 200, 300, chalo, up to million I am okay. So what I do is make the first query. Okay, then I make a hash table of account number and date. Account number and date, I make a hash table of date between two and. So what do I do? Construct a hash table here. I'll add back in my notepad. I'll construct the hash table which says that something like 1, 2, 3, 4, 5, 6. Oh, Marathi, not Marathi. 1, 2, 3, 4, 5, 6. This is my hash table key, followed by date, say 2021 03 21 to 2021 03 23. This is my hash key. So for this account number, this is the date range. Sorry, this is the date range. Maybe I'll put some dash or something. 2, 1, 0. Now this is my key. Okay. I query once and store the result in the value here. Next time, I look up in my hash table first to say, does this already exist? Then I know the value. I don't have to go back. But if it doesn't exist, then I go fetch it and add it to myself. Next account number was say 999999 and date was slightly different, or maybe the same date. Doesn't matter. We'll say, okay, I got this one, and this value was whatever. Value A aa gaya, or table A aa gaya, whatever. This is a value B aa gaya. Third guy comes. So first 100 times I get the hit. I cannot avoid that first 100 times. When I'm going to start making the query for 100 accounts one by one, I have to do that, possibly. Or I could do a more cute query which said group by account name, and I'll give this as a parameter. That's also possible. But in my code, I'll say, okay, these are the 100 people I know. I'll read them from somewhere. I got their answers. Now I got everybody's data in me. Then I say, if somebody asks for this again, or if I have to get this again, I look up my hash table first. Is there a value there? Yes, then don't query, it's already here. No need to spend that 1 second going to America and coming back. Okay, what's the downside of this? It is upside, is that I get quick answers and my user interface looks really fast and beautiful and it responds very well. What's the downside? What's the bad thing happening here? Could happen here. I might get obsolete data. In my database, this account, I queried it and I'm playing on my account. In the meantime, somebody closed the account. I still have the old data when it existed. So I have wrong data now. Obsolete data. It changed in the middle. What was my query? I gave current balance. During that time, somebody's balance changed. So I got old data now. The correct way to do it is always query the database. But that's where your algorithmic power comes into picture. You say, realistically speaking, it's not going to change. 99% time, it doesn't change so often. So I'm okay with caching it as long as I don't depend on it for further transactions. So if I use this, so for example, you get this one, then you say, can I deduct so much money from your account? If that query comes, then you say, okay, wait. There's a query coming which wants the real-time value, not just for display purposes. I'm going to query one more time just to be sure. Query it again, replace the value new that comes here, this value A dash. So you keep a state of that object in that entire thing in your memory and make sure you want to, every time is there going to be a critical business decision going to happen on that one, you query the real one. 99% times, you'll be fine. For that 1% time, you'll spend 1 extra second. It's okay. It is going to be a practical decision, not a purely philosophical decision. Pure philosophical decision is always query the SQL server because that is the only one that gets the exact state. But from the point of performance, I cannot afford this because my customer will go away. If every time he does something, I take 1 second to get the answer back. Okay? So here are things. So what would I do in this case? If I say local DB, the DB is sitting on my machine, I will not bother. Most probably, I will not fetch, I will not, what do you call it as, worry about that 1 second delay because my local DB will not be so bad. If it's the remote database, then I have got a biggest problem. Do I do aggressive caching? So what I did was aggressive caching here. Okay. Do I do a local cache server here? In the sense, I have another machine which caches it for me and gives the result in my local network. So it is much faster for me. So that machine is a big machine which keeps on keeping the state of the server on a time basis. So every 10 seconds it goes and queries everything. It doesn't care. It's ready with the answers already, having a state of the machine. Is it local cache server? This will be good if you are running a web service. So if you're running a high traffic website which has to query certain things, you keep a local cache server. Your data actually sitting somewhere or Azure or IBM Cloud or somewhere. Because the transport is very slow, you make a copy of it, do it here. Worst case, sometimes you get a mistake. At that time, you say, oh, need to refresh the web page, refresh the web page. So as long as the software, your problem is solved 99% of the times, or for 99% of users, you are fine. Those 1% user will have to refresh, that's okay. So always, it is practical decision. All algorithms, pure algorithms never work because you always have these things. Now, in that 100 ka thing, will you do a linear lookup, binary tree or hashing? Well, all three are good algorithms. Linear is of course order n. But does it matter if I have only 20 accounts? It doesn't really matter. Like, theoretically, yes, it does matter, but in practicality, it doesn't matter. Okay? If it's a reasonably big tree, if it's a binary tree, so if I have the less than, say, 256 entries in my table, so I'm going to hit 8 times. 2 raised to log to the best 2 of 256. So maximum 7 hip hops, I'll get the answer. No need. Oh, I've got 1 million entries. Oh, that's going to be tough. Let me do hashing. Then measure the performance of the hash function itself. Because hash function is order n again. Right? Hashing says I can give you the answer in order constant. If you've seen that, you must be teaching algorithms at school. So in the colleges. So hashing has got a order constant. But hashing function itself, is it expensive? After hashing, yes, it's order constant or close to constant. And when to invalidate the cache? So I told you, when a business decision comes in this scenario, if I'm going to do something with that balance, like take money from that account, generally speaking, if I'm going to deposit, I don't care. But if I'm going to take money from that account, will this credit card swipe pass? I'm swiping the credit card. It goes to that thing and says you've got 10,000 rupees limit. Then I come in here and I know I've got my limit. If I'm not spending, I don't really care if that limit is changed in the behind. I only care about it when I go to spend. So I could show in my dashboard, beautiful, you got 10,000 limit. Last I checked was, 20 seconds back, you had 10,000 limit. In the meantime, your spouse swiped the card in some other store, your limit went down. I still have the old 10,000. You already spent 10,000, Meka. You spend 5,000 out of it, you have 5,000 remaining now. But if I go to commit a transaction, I'll have to go and check. I'm going to try to make a charge of 10,000, 7,000. Will it pass? It will not pass because in the meantime, 10,000 becomes 7,000. So when to invalidate? When you start a new transaction, which depends on this value. So this caching is beautiful when you're showing in the UI. As soon as you start acting on it, you will do the real thing again. It's all smoke and mirror bolte hai na jise. What we call it is, this is all show. All facade. But that makes your software look beautiful. And it gives great user experience. Because nobody does it all the time. Okay, let's do another very interesting example of spell checker. Actually, I worked on it myself.
Everything for everyone.
WordCast spell checker and all the office spell checkers, they came under my team for some time. And at that time, we were doing this. The first 2 spell checkers were written by a third-party company. And then Microsoft wanted to write their own. So we came with a spell checker team, which had like 4 or 5 linguist people. And then 4 or 5 really, really excellent programmers. Brilliant engineers were there. And the idea was the specification first line was offline. Online didn't exist in those days, but later we added it. Suggest words, add custom words to custom list, allow additional alternate dictionaries. So this made sense in those days. It doesn't make sense anymore. But what is the idea is that as I type and I say F7 key on spell check, it is supposed to suggest me words. So what algorithms and data structure do we use at the back? Now this is all 20-year-old information. So, and everybody knows it anyway. So I'm not telling you any secret here. What did we do is that we used this, remember this thing? 2, 3 interesting things we did. First was that we said commonly made mistakes. THEHT, people type it like this. Slight of dyslexia. Lot of time order standard way of making the spelling mistake again. Okay. That's one. Secondly, then we actually looked at the keyboard layout. So somebody types instead of man. Okay. Somebody types mab because N and M are close by. Or instead of something like Sam, they type Sab or San. So we actually look at the keyboard layout and say this keyboard layout, the nearest keys are this. So possible choices are between these keys that this guy made a mistake. So we had dictionary of all the English. It was English, French, and those days English, French, and what was the other one? Thai was there, I think. Thai is weird, but and Arabic was there. So Hebrew was there, yes. So for 6 languages we were doing at the first shot. So English, we got a huge dictionary from Oxford. We had 2 dictionaries, one for American English, one for British English. COLOUR versus COLOR, that kind of thing. Okay. In those dictionary, we did something like this. Remember, I showed that try thing, pattern matching. First character is this, second character is this. So we dissected the dictionary and made it into our own data structures, which I'll show in the next part. See, we read the indexing algorithm for dictionary. So what we did was that we prepared the dictionary in a way that first character is A, then the choices are only this. Okay. Then the second character is what? Again A. So A ke andar there was a tree at the root level, which was A to Z tree, followed by a subtree under every level of every character. But we didn't go overboard with up to last character. We stopped at the 3rd or 4th. After that, it was a simple linear search. Okay. So you have to, so classically speaking, I would have made a tree for every word, a tree item for every word. That would have been bigger than dictionary itself. So what we did, we went out to 4 or 5 characters. After that, practically speaking, spell checking can really determine the word because there are only 4 or 5 remaining now. So beyond that, it was a simple linear search. Actually, we did a binary at the end because one of our programmers was extremely mathematical. Guy said, no, linear search is bad. Okay, do binary, fine. Don't. Okay, so he did a binary search even at that last things. But then we told him if it is more than 8 entries after the first 4 characters, there are certain words like that which generally start with COM. So compensation, compendium, something, there's comprehension. There are so many words which have the first 4 characters the same. So those kind of words we had a binary search, or something like weird words like partition and party. PARTI ke baad mein there were only possibly 2, 3 or 3 words. So we just looked them up directly. So that was the algorithm. Algorithm was what? Send the word to me, look at the first character, go to that tree, look at the next character, go to that tree, do it 3 or 4 times. After that, there's a list of words. Is it matching in that? No, it's a mistake. Then quickly go and apply the Levenstein algorithm to say which is the closest match, show that suggestion. Okay, then this guy says, add custom words to custom list. Then he says, you know what, I think this word, Makaran, is a good word. Don't correct it, it's my own name, it's a custom word add to list. So they would say in the UI, I don't know what's going to happen in the UI, I don't care about the UI at this point. UI is something that the user interface program will do. This is my, what do you call it, the module that is doing spell checking. So it gets a call, this word add to custom list, because it's shown in the thing, then it says add to custom list. As soon as it goes to custom list, I put it in a secondary tree, a parallel tree. So I look in my first tree. If it fails, I look in my second tree. If that fails, then I say it's an error. And sometimes I don't even have a suggestion for you. If you type Z, 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 I don't have a suggestion. There's no word that I can tell you which starts with Z, Z, Z. And then the next step, what we did is that if it did not get a good suggestion, we would look at the close by keys. So instead of, if something started with R and it didn't find it, we would say, oh, let's try T and E, which are next characters in the same line. So this algorithm took about 2 to 3 months to finalize. And did we catch everything? No, we caught 99% people's 99% cases, good enough for shipping. Okay. So what did we do here? We did these 2 things. We prepared the indexing algorithm for the dictionary. Okay. So that was the biggest task here, was to prepare the dictionary in a way that we can really search it quickly using like the pattern matching algorithm. And in the runtime, we used to use that indexed data to a great extent to quickly find the word. So was it one algorithm here? No, 10 to 15 different algorithms were used to make that one piece work together. There was a binary search, There was some kind of a TRI, like this map tree. There was a tree algorithm there. There was to a certain extent, there was this two things look up. So parallel processing, one thread would look at this dictionary, other will look at the other dictionary. They'll come back together and get the suggestions. And then the V2 specifications, they do this while typing. While typing, now you see in Word, right? In while typing, as you type, immediately start putting the red wiggly line under. Okay. And then the last one was, I start typing in English and suddenly change my keyboard to Hindi and start typing in Hindi. It should pick up the correct language and apply the correct speller. So now what we had in memory? We had two spellers or two spell trees in memory at the same time. Because a lot of people do type multilingual documents. This is very common in the European Union, but they have to write in French and English. Canada, they have to always write in French and English. Then typically most of the Middle Eastern countries like Dubai, I believe, is English and Arabic. If you go to Algeria, Tunisia, Morocco, it's always French and Arabic. In India, we always have the three languages, so Hindi, English, and in the same document you have the local language like Kannada, Marathi, whatever. If I do a spell checker on that document, it should pick up three different dictionaries for three different. And this is not always true, because if I'm typing here something like this, this is not, you cannot solve all those things. If I type, is it a good word? In English, no. In German, yes. Right? If I type this in English, it's bad. And most probably you say, oh, you want to say less. But if I'm in French, less is good. Less is the in their word. It's difficult. Just by looking at this, I cannot tell if its spelling is wrong, unless I know the context of what language we are looking at. So sometimes, no. We say your current keyboard that you are typing, which you see here in the screen, is English. So most probably you are typing English. So this is a misspelling. And if this was changed to French, I would say this is a misspelling. Because I will change the speller under the table for that person. And actually, I think Word XP onwards or Word whatever 2000, whatever that was 10. We actually started doing that in Microsoft products. We started looking at the keyboard and say, you know what, this is English, so put English speller, not the German. If you're typing in German, so don't say der is a bad word. Der is a good word. All right. So this is what my take on algorithms is. No, this is not one size fits all. There are a bunch of standard algorithms available. You have to mix and match and do your own. Always. It has to be for the use case. It is not a generic solution at all. It's not like ready-made shirt. You